These are notes for Honors Math 3. This is objective 9.12a, where we'll be writing equations of trig functions. So on this handout that you have, you can see that we'll be starting with writing the equations of sine graphs. It then goes into cosine, tangent, cotangent, and then at the end we'll be doing cosecant and secant graphs. So I'm not going to go through every single example, but I'll go through several of them here. So in this first section, we're going to start with problem number 1. So I can see my sine curve in here reaches a maximum before a minimum. So as I'm writing my equation, I know I'll want a positive sign. Okay, some of the others you can see a negative sign graph when we reach our minimum before the maximum. So we've got a lot of positive sign graphs here. Because you're writing equations on all of these, you want to start by writing either y equals or f of x equals. And then I'll go ahead and plug in my function. So you really just want to go through your checklist of all 4 values that affect a trig function, a, b, c, and d. So a value comes from our amplitude, the value of b affects the period length, c and d affect the horizontal and vertical shift. So you'll notice here that we have our first last points right on the x-axis. You've got a max of 1 and a minimum of -1. So we are certain that our equilibrium here is on the x-axis. And my first point is on the origin. So I can tell my graph has not translated left, right, or up, down at all. So we're not going to have any values here for C or D. A, our amplitude, so up 1 from the equilibrium or down 1 to the max or min. So it is going to be a positive 1 that we'll start with here. And then B affects the period length. So notice beginning to end, 0 to pi is a total distance of pi. So we'll take pi and set it equal to our formula for period of a sine curve. 2 pi divided by b is pi, so b must equal 2. So in writing our equation here, we'll have a positive 1 sine, then a 2x, and we won't need any c or d, so we'll just end this way. So we're going to jump over here to problem number 3, and we'll do the same thing. Start with our y equals. I know I'll need a negative sign since we have a negative sign graph. Again, I can see the first and the last point here are on the x-axis, and so my equilibrium again is the x-axis. That first point is on the origin, so I can see once again there's been no translation left, right, or up or down. Okay. The a value, so distance from our equilibrium up or down is 1/2. And since it reaches the minimum first, that's why we'll have our negative 1/2 here. The only other thing we need is the value of b that affects the period length. So notice beginning to end from 0 to 2 pi over 3 is a distance of 2 pi over 3. So we'll set this equal to our formula for period length, 2 pi over b. And we can see here that b is 3. So we plug that in, bx. And just in case you forgot, let's write down what that should be. So y is equal to a sine or cosine or secant or cosecant or tangent or cotangent, b x plus c plus d. So the translations left, right, and up, down. All right, so let's do number 6 here because it's got a translation on it. We can see once again from where we start, we're going to reach our maximum before our minimum. And so it is a positive sign graph. I can see the equilibrium then here right at 4. and to the max or the min is 2 units. So that A value is 2, and that's my leading coefficient. The period length from beginning to end, so here where x is 0 to the last point where x is 2 pi is a total distance of 2 pi. So the period length hasn't changed and the b value will be 1. If you want to see that written out like an equation, we can always set it equal to. The formula for period is 2 pi over b. So 2 pi divided by 1 will give us 2 pi. So b is 1. Now, sine likes to start on the origin, and this sine graph is no longer on the origin, but it's been moved up 4. So we want to have a plus 4 here at the end. Okay. The b value is 1, so we could write 1x, but we'll just write x. So 2 sine x plus 4 is my equation. All right, so cosine will follow the same pattern, and we're just looking for these 4 values if we have them. So in the next section, we're going to start here with problem number 7. You can see that it's a positive cosine graph. So we have our 2 maximums, the minimum in the middle. Notice that's a height of 3, a minimum of -3. So the equilibrium is my x-axis here. Okay, and that tells me that the graph has not been translated up or down. It's still splitting the x-axis equally. Okay, so in finding our values here, it's not been translated up or down, but it has been translated left. So that A value from the equilibrium to the top or to the bottom is 3. And cosine likes to start on that A value 3. We can see that from there on the y-axis at 3, it's been translated left 450 degrees. All right. For the b value, we're just going to measure the period length here. So from -450 out to 270, so 450 plus 270 is 720. So it's just in degrees instead of radians. And so instead of 2 pi over b, 2 pi is 360. 360 divided by b. So you'd have to divide by 1/2. Right? Dividing by 1/2 is the same as multiplying by 2. 360 times 2 is what makes 720 there. So the b value is going to be 1/2. And we'll write our equation. So we have +3 cosine 1/2 of x. It's gone left 450, so we want to have plus 450 degrees. And then it hasn't shifted up or down at all, so there was no plus or minus anything here for the d value. Okay, we're going to go on to number 8. So this one's also a positive cosine graph, but it's been moved down. You can see it's not equally splitting the x-axis on top and on the bottom anymore. So 3 to -11 is the total height. So that's a total distance of 14. So the middle here should split 7 units and 7 units. So this is running through at -4 right here. So that's 7 units up and 7 units down. That's our A value, or that's our amplitude, 7. And because it's a positive cosine graph, we will start with a positive 7. All right, so B, C, and D. So cosine likes to start on the y-axis at that a value 7. From there, it's been translated 4 units down to 3. So my translation is down 4. So D is going to be a negative 4. Okay. C. So from here, it's not been translated left or right at all. It's still on the y-axis, so we're not going to have a C value. And then the B value is affecting the period length. So starting here on the y-axis with an x value of 0 to here where we have an x value of pi over 2, the period length there is pi over 2. So we'll set that equal to the formula for period, 2 pi over b. And solve here. So we're going to end up with b is equal to 4. And you can check that 2 pi divided by 4 will reduce to pi over 2. So this is a 4x. Again, there's no translation left or right, so I'm not going to need any parentheses there for that. I just want to subtract 4 at the end. All right, so there's that answer. And that's all we're going to have for the cosine graphs. I just realized this should be a minus here. There we go. Make sure you have a minus sign there. That's what that formula should be. Okay, let's move down to the tangent graphs. So these aren't so bad as you might think they are. Okay. So we have these 3 here. We're going to go ahead and look at problem number 10. So it does say to write it as a tangent graph, so we want to start off that way. Thinking about it as a tangent graph, left to right, this graph is increasing. Positive tangent graph does that, so I want to make sure it is a positive tangent graph, so my leading term will be positive instead of negative. That leading a value is that distance from the center point up to the next point or down to the next point. So that distance up is just 1 unit up and down. So a positive 1 leading coefficient, which I don't need to actually write. So what about B and C and D? So B affects the period length, so we'll just look from asymptote to asymptote. So I've got pi over 4 on the left, 3 pi over 4 on the right. So that's a total distance of 4 pi over 4, or pi. Now, the period length for tangent and cotangent is 1 pi over b, not 2 pi over b. And so in this case, b is still 1. So 1 tangent, 1x. Now, the translations, this middle point of tangent always starts on the origin unless it undergoes a translation. So we can see that all that's happening here is a translation right pi over 4. So C is going to the right pi over 4. So we have parentheses here, x minus pi over 4. And because that point is still on the x-axis, it's not been moved up or down, there's no value of d to change here. So this is all we'll have. All right, so let's take a look at number 12. So again, I have another positive tangent graph. Now, I have a point here on the origin, and then we've got these points nice and evenly spaced apart between the asymptotes here and the center point. So we see up 3 and over here down 3. So that's the A value. So it's positive 3. So next is the value of B. So that's coming from the period length. So asymptote to asymptote is pi on the left plus pi on the right is a total distance of 2 pi. The period length for any tangent curve is pi over b, and that period length is 2 pi. And so you solve for b, and you end up with 1/2. So b is 1/2. There's no translation left, right, or up, down, because that center point is still on the origin. Remember, tangent 0 is 0. So this will just end with a 1/2 x. No translation left, right, or up, down, so there is no value of c or d here to change. So we're going to move on to the second page and look at some of our other graphs. So we'll do a cotangent graph first. And we'll go ahead and do number 14. So we have one asymptote here along the y-axis. The other one's over here at pi. When you graph cotangent, we always have that one asymptote at 0 unless there's a left or right translation. So since it's still here, there's been no horizontal translation. So out of all your values here, you don't have a c value. Notice though that that center point that should be on the x-axis has been moved up 1 unit. So d is +1. Okay, because I can see this point here should have been on the x-axis, but it's been moved up 1 unit. Now, the distance from this point up or down to the other 2 points is 2 units. So that's my a value. Positive cotangent left to right is a decreasing graph, so it is supposed to be a +2 for that leading value. So +2 cotangent. I'm going to have a +1 at the end. I just need to know my value of b. So this comes from the period length. This distance between asymptotes is pi. The period length for tangent or cotangent is pi over b. And the period length of this one in particular is pi, so b is just 1. So cotangent 1x, and then +1 here. All right. Let's take a look at the next section, which is secant. And we're going to take a look at 16. So inside a secant graph, you're just going to look for cosines. So the maximums here, the minimum here. You can imagine in the middle. So let's take the middle here. So 3 and -1. In the middle would be +1. So that's going to be my equilibrium. And where the equilibrium meets the vertical asymptotes, that's where those other 2 points for cosine would end up. So just so you can see the cosine curve in here, if you're looking for it, it is a positive cosine curve, so this is a positive secant curve. All right, now I've noticed that that equilibrium is no longer on the x-axis. It's been moved up 1 unit, so there has been a vertical translation of 1 unit up. But that starting point is still on the y-axis. So although it's been shifted up 1 unit, it's not been moved to the right or left, so there won't be a c value here. So let's talk about a. So that should be the distance from my equilibrium to the maximum, or the equilibrium to the minimum. So that's 2 units up, 2 units down, and a is 2. For the value of b, we're just looking at the period length. So beginning to end of cosine, we have a total length of 2 pi. So the period is just still 2 pi, and just like it is for cosine, 2 pi over b. So b is 1, but if you'd like to see that by writing the equation, you can see that and solve for b to get 1. So I'll have 2 secant, 1 x not shifted left or right, so just one x, and then a plus 1 here. All right, which brings us to a cosecant graph. We're going to look at number 19. So inside of cosecant, you can find sine, so maximum, minimum. That's at 2 and negative 2. So right in the middle should be my equilibrium. In the middle of 2 and negative 2 is the x-axis. So right where the x-axis and the vertical asymptotes meet, that would be my other 3 points for sine. So you can see the sine curve in here, if that helps you. So notice it's a positive sine curve, so this is a positive cosecant curve. My leading term is that distance from the equilibrium to the max or to the min, which is 2 units. The b value comes from the period length. So we're going from negative 60 to some unknown value. Now, they gave that this first vertical asymptote is at negative 60 degrees. This one here is at 120. So this distance is the same as this distance. And it's really just the distance that I need to know. So negative 60 to 0 is a distance of 60. To 120, so 60 plus 120 is a total distance of 180 degrees. So this is also 180 degrees. And I have a total length. This is the period length of sine, so it's also the period length for cosecant, the total period of 360 degrees. So all together. So period is always 2 pi over b. In degrees, 2 pi is 360. And so once again, b is 1. So 2 cosecant, 1x. And hopefully you can see it does have a horizontal translation. If we were basing this on the graph of sine, sine likes to start on the origin, but that first point has been translated 60 degrees to the left. So c is negative 60. So we have x minus negative 60 degrees. And then it's not been translated up or down at all. So this will finish off our equation. So your worksheet for 9.12a looks very similar to this one that we did for the notes. So you should be able to get through most of those problems okay, and then we will go over your questions during class.